Okay, in this second video, I'm going to show you how to set up the equilibrium expressions and then we're going to calculate K and Kp. So I'm going to begin with, let's see, the following reaction. Hydrogen gas plus bromine gas giving me 2 HBr gas. They're all gases. So the equilibrium expression would be raise it to their molar power and the Kp expression would be the same thing, except then it would be the pressure of their gases. Okay. Now, anything that you can do in algebra, you can do with a chemical equation. So suppose that the reaction was written like this. Oh, I should get used to writing the double arrow now. So how does, I'm going to number these, reaction 1, reaction 2. So how do those two reactions differ? Well, in reaction 2, everything is just half as much. So if I was going to write the equilibrium expression for this, it would be right? But now this K and this K cannot be the same thing. Because obviously, if I am squaring up here and not squaring down there, well, that's going to give me different answers. So these two Ks are different values. So how do I distinguish these two Ks from each other? I'm going to call that K prime. So how are K and K prime related to each other? Well, basically, I would have to take the square root of this reaction to get this expression down here. So as you know, if you do something to one side, you're going to have to do it to the other side as well. So the square root of K is going to equal K prime. Or to put it another way, K to the 1/2 is equal to K prime. How about, I'm going to rewrite reaction 1 so we can see it. How about this and reaction 3? Now my reaction is doubled. So my expression, I'm going to call this K double prime, would be this. Forgot my tooth there. So how would K and K double prime relate to one another? Well, what would I have to do to this expression to turn it into this expression? Well, I'd have to square that whole thing. If I'm going to square one side, I'm going to have to square the other side. So K is going to be related that way. So if you were to triple the reaction, you'd cube it. Same idea. Now I got one last one to do for you. What if we were to flip the reaction? Now I get this expression. I'm going to call this K triple prime. My products are now hydrogen and bromine. So now how do I turn this into this? So the way I'm going to do that is I'm going to flip this, do 1 over. So if I do 1 over, that means 1 over K is equal to K prime, K triple prime. So if I flip the reaction, it's 1 over. What's another name for saying 1 over? K to the negative first. Okay? So if you flip the reaction, your K is going to be 1 over K. All right? So there'll be problems like that on your homework. The next number I'm going to do is number 27 out of the book. It says at a particular temperature, a 3-liter flask, this is on page 644, a 3-liter flask contains 2.4 moles of chlorine, 1.0 moles of NaCl. It contains 4.5 times 10 to the negative third moles of nitrous oxide. Calculate K for the following reaction. Calculate the equilibrium expression. So my equilibrium expression is going to be products over reactants. I'm going to raise it to its molar power. Now, are there any liquids or solids in this reaction? Because if there are any liquids and solids, remember, we do not include them. But everything here is a gas. Let me make that a better G. So everything is included. And the NaCl is raised to its second power. So now I have to plug in their concentrations. Well, they tell me the moles per liter. So I'm going to have to calculate the concentration for each of these. So my chlorine would be 2.4 moles over 3 liters. There would be 2 sig figs on that. The NaCl, 1 mole per 3 liters. And then for the nitrous oxide, be 4.5 times 10 to the negative third moles divided by 3 liters. .0015 molar. So now I've got my 4 concentrations. So sometimes they give you the concentrations in molarity, then you're all set to go. If they do it like this, then you got to calculate the concentration first. And obviously, if they gave you pressures, you'd be calculating Kp. So now I can plug them in. That would be squared. The chlorine is 0.80. Oh, that's molar. That's molar. And then we divide it by the NaCl, 0.33. Now, for whatever reason, they don't put units on equilibrium constants. So even though I put molar, 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 they don't put any units on the equilibrium constant. So my equilibrium constant is at 5.45. Oops, no, there should be 2 sig figs, so 5.5 times 10 to the negative 6th. Okay? So that's what your homework's going to be like for, and I'm just going to list your homework problems. I will also put them in Canvas. First of all, I want you to read pages 607 to 618. And then I want you to do numbers 23, 25, 29, and 31. Okay, so those 4 problems. Have a great day.